Dr.
Thank you.
Sanguli is on the line.
Yeah.
Okay.
Thank you.
Okay, you can share your screen.
Yes, I can. I will share my screen first.
Okay, you can do it now.
Okay. View. Okay. Okay, I think I'm ready. Okay. May I start now then?
Yeah, please.
Okay. I'm going to talk about my experience to develop and offer a new online course on introductory math for AI. Okay. This semester-long introductory mathematics for AI course was developed a year ago, and we wrote a curriculum and a new textbook and provided a online mathematics lab, which is the core part of today's talk. And I exercised the process-driven. Oh, why this page is not changing? Hey, did I share? Right. Okay, I will share my screen again. And this goes. Okay, yeah, now it's moving. Okay, yeah. So the process driven evaluation method was properly used, and PBL report was made by a student, every student, and I found this class showed a significant progress of student performance. So in this talk, I'm going to share my experience from this course. Okay, due to the COVID pandemic, we had to start to offer a class online, and AI is being actively used in almost every field. So I was asked to develop a mathematics course, which the student who has an interest in AI should know before they get into deep in AI, particularly the mathematical background. So we developed a curriculum and textbook, and it can be shown in this web address. And the book can be found. It was written as a formal textbook, and also ebook was made on this address. And I also developed the mathematics online lab, free online lab, which support this course. These two are novelty of today's talk. And because of this new class had its own aim, so new evaluation techniques was used, and I urged the students to actively involved in the discussions to understand the mathematics for AI. I used Q&A board effectively, and that was the kind of key factor to succeed this learning and teaching experience. And PBL report was made by freshman student, which can be shown in this web address. I will explain. Okay, and finally, student presentation of their own final PBL report was recorded, and peer evaluation was made even in the online class, because each student recorded their learning experience and their accomplishment throughout the whole course. And this is the textbook that I wrote, and the the contents can be found on the here, the lecture note and lab. I will show this first. Okay. I have to I have to share this web address. Okay. Here. Okay. This is actually this my lecture note and laboratory explains pretty much of what I'm going to talk today. It has all the content on for all the, mathematics which is needed for artificial intelligence. First, the basic mathematics and the linear algebra background, including singular value decomposition and solving the system of equations, and the calculus knowledges, particularly the maximum and minimum and gradient descent method, then iterative methods to finding the optimal solution, and then statistics, particularly the covariance matrix, which can be made from the given data. Then principal component analysis did use all the mathematics that we have learned in the early part of the class. And then back propagation algorithm was fully explained to our freshman student. And this is a key idea to understand the machine learning process and artificial neural network. The freshman student even did understand these ideas and the mathematics that makes work these AIs working properly. And each here, it has most of the textbook in here, but important things are in here. For example, in the first week, here, and this is the first week of the basic mathematics of AI. The key idea here is they start from the function and draw plotting the graph of it, make a sketch of the given functions. And this is very important to find the solution of the polynomial equation and the iterative, to understand the iterative method to find the approximate solution of a higher degree polynomial, to find the eigenvalues of a matrices and the singular value of the matrices. Okay, and this, all of these tool and lab was developed so students don't need to buy any software or any particular programs and tool. They can do all this with their own smartphone or laptop or tablet or PC or whatever. And they started to draw the graph of a function to understand the behavior of the function, to find the maximum and minimum, and then we could easily start it from here. And I will continue. Maybe okay, and I will get back to my presentation here, and then we can as a student learn not only the problem, the content and concept, but examples with solutions, and also the code was supplied. So students only have to check the solutions, how this code give the solutions like this, and it visualizes it and it gives the iterative solutions like that. So after I teach one problem, one example, all students can solve all other problems in the homework problems, whatever. And I made the good way of making them to study without much difficulty. Even they are just got out of the high school. They could. And this is what the students have learned. And so the student was, I asked them to actively solve the problem and share their solutions and to talk about it to make a better solution. So all of those student activities was gathered to make their own report, midterm and final report. And this is the result which was made by the freshman student, the new student from just got out of the high school. I will show this. I will share the screen here. So all of this is more than just one out of the 14 weeks lecture, and got out of the freshman students, the Kim and Giri, and the freshman. And they said they have learned finally this SVD and gradient descent method and the principal component analysis and rank reduction in PCA and back propagation algorithm and machine learning. And they started to summarize it. These are this homework was I gave a format of the report, and they filled out the empty spots. So they stated more than 10 mathematical definitions and concepts they learned in the first 14 weeks in here. So they said they learned this and this, and they and also they had I asked them to have a project proposal, just the idea. I do not ask them to complete this project, but voluntarily, yeah, some students may finish their project, but just I ask them to use the mathematics to use their own problems, to try to state their ideas. Some students finish their project. This is by the freshman student, and also I gave them self-evaluations. It's a chance to evaluate by themselves, and then peer review. I asked them to evaluate other students who helped him in the learning process. And these are the about 200 pages activities. Start from the introduction and motivation of taking this course of student, and then solving the problems. They solved the problems in the textbook, open problem 1, 2, 3, 4. I gave about 30 problems, open problems, so they can try. And so they drew the graph of it. They found the eigenvalues and singular values of the given matrix and started like this. And it went through all the way to the back propagation. They talked about the histories, and also they developed the code to handle the problems. They made a covariance matrix from the given data, and they shared it and they discussed it. What I found interesting is so they really have done a data analysis even when they were a freshman student. They were able to generate find the principal component, and they were able to do the rank reduction of big data. So at the end, I asked them to write the final comment after the report. And here they said the first 8 weeks they learned something, and eventually after 14 weeks they learned this, and overall they have learned really a new and interesting experience that will help their career in whole. So that's what that's why I like to share those experience. Okay, now I go back. I think I have about 10 minutes. Okay, so these are the appendix, and here you can find the textbook and on this web address. And also I gave the lectures in Korean and I gave lectures in English here. So you can find how I did explain these important mathematical concept which is needed for the all student who has an interest in their career in data science and AI on this. I explained it very easily. And also the lecture note and the lab can be used, can be found in here. It's all free. So all you have to do is just go in and take a look. Then you will see what I have done. And these are the main ideas. I taught in linear algebra, the singular value decomposition was a core part. So I went through the very quickly to reach this point in a very short time. Usually, my major is a matrix analysis. So I spent one semester to teach singular value decomposition usually, but I taught this in 2 weeks. And I taught the gradient descent method. This from the calculus of multivariable with the multivariables. And this is core idea for AI. And data and covariance matrix in the statistics part. So, and then I used all this to reach the principal component analysis and back propagation to make our students understand this in 14 weeks. And 1 week for the evaluation and presentation and exams. And teaching and learning method was developed and exercised. Yeah, it was online because of the situation, but I used the flipped learning techniques and portfolio, the PBL report, and peer reviewed, and student presentation and academic activities, and were used. Okay, so process-driven pair evaluation management was not easy, but it went through because every student activities were shared in bulletin board, so every student could see others' activities, question, answer, solutions, discussion. So yeah, it was when, and also learning management system was used because we were using in online, so it wasn't that difficult. And then Q&A was a vital factor on this course. Okay, here I may show a new type of true-false quiz problems I used in the class. I asked them, I gave out about 10 problems of such this over 5 points, for example. I have done and shared my solution and my experience on a problem in the textbook, and I finalized in Q&A. And now I can explain the orthogonal projection or least square solution, and I can find the least square solution for any linear system of equation with the full column length A of A. So in order to get full credit on this, student had to actively involved in the class, and I will that worked very well. And the course management, I listed in detail how did manage my class, which was successful. So you can go through it. I actually submitted my paper, all of this, to the Electronic Journal of Mathematics and Technology. So you will see it sooner or later in full detail. And the data was generated, and from the attendance, quizzes, and report and exams and presentation, etc. And those data was analyzed by principal component analysis, which is a core part of our class. Many of the mathematicians or math educators may heard for the first time for the principal component analysis, but it's a very easy concept if we have a very basic mathematics. And those techniques, I actually applied it to my data to analyze it. So I found the principal component 1, 2, 3, 4, such as this. What this means is in the cluster analysis of those data shows these three groups. These are the grade the student got. And we can see that there are three groups like this: A plus A's and B plus, and B, C, and D, and C, D, F, like this. This clearly shows it. And what kind of factor was really effective on the good to have a good grade. And this shows it. PC1 and PC2 hold the 90% of the impact on the final grade. So what the student learned was really worked. These are the 6 axes: PC 1, 2, 3, 4, 5, 6, and project presentation had a pretty much of impact. This is clear. The student, this was not a mandatory. So those students who finish it or give a presentation of their project was that means they had a confidence, so they really understand it, they can use it. And so that really matches it. And this is a course evaluation, and it was exceptionally better than before, when I did not use the method that I used in this course. So as you see, it's far ahead of all other courses on the teaching evaluation. The first one is a self-evaluation. So students told they could do better, they could work harder, but they are satisfied. They learned a lot more. They was interesting, and it will be useful for their whole careers. And the example of those the response can be found on the student portfolio in here. There are many, so you can see this. And these are the students' comment on the course. And these are the final comments that I mentioned earlier of this talk. They really understood this in one semester, freshmen. So those students who understand this can really build up. They learn a lot of the knowledge while they are in the university. So very well prepared for the lots of the very best jobs in the world. So it was very meaningful to me. So I shared my experience with you today. And this is a conclusion. I learned the 15 weeks. I developed a 15 weeks one semester course, and particularly designed for the college freshmen. And it was offered under the name of the Introductory Mathematics for AI. And it was consisted of linear algebra and multivariate calculus and statistics. And to understand the PCA, principal component analysis, and backpropagation algorithm in machine learning, it went very well. And I think others can refer this on their need. There was a references I used about 30 reference books and papers and website. But in addition, the textbook that I wrote in Korean and in English. This is an English book, and the web content, lecture note, and the lab. Everybody can use this lab, and that's my lecture note and student portfolio. I think that's the things that I like to share today. Okay, if you have any question, I'll be happy to answer.
Okay, thank you very much. Your topic is very interesting.
Thank you.
Especially when the students have to work from home, they can do your program very interesting. Okay, we have another 2 minutes more. Any question from the floor?
I'd like to ask a question.
Okay,
Thank
please.
you.
Hi, thanks for your sharing, very generously sharing your material as well. I will certainly take time to watch your YouTube videos one of these days. I have a couple of questions related to the course itself. You mentioned 14 weeks. So how many hours per week?
3 hours, 3 credits.
3 hours. So it's 14 times 3, 50. 14 times 3, yeah, 50 over
3
hours.
credit, yes, 3 credit class. Yes.
And may I know, because I think your students will have to do some programming using Python. Is Python taught inside, or they already know Python from somewhere else?
That's the key idea. The college freshmen, most of them don't have any idea of the codings, particularly Python.
Yeah.
So I debate. If you take a look on my lab, then already the code, Python-based code is given there. All they have to is just
modify.
click it. Then there is a solution there. The code there is a function, and find something, solve something, plot something. So even though they don't know anything about it, if they can read it, they know what to do.
Yeah.
So they can modify those code, replacing by the function and matrix and the conditions, the intervals, all done. So after every student without any background of the coding or language, they can go through it, they can change it. So after finish it, they realize they have learned the Python-based computer language, and they can use it in any time, in any course. So they were very happy to take this course before they take the other math courses. So they can use this code to solve all the problems.
Okay, that's very interesting. And just one more question regarding assessment, because I saw you later on, you actually analyze the students' performance, failures, and so on. What assessment? Like, is it a typical mathematics exam kind of assessment?
Typical assessment.
That means is it that they sit down and then they write pen and paper?
Oh no, we were in the pandemic, so we couldn't meet. So I gave the online quizzes or online exams, but PBL report is more important because I made those exams particularly comes out from what we have done, what we have shared in the PBL, in the Q&A bulletin board. So I made them. So I just check whether they have really done or what they have really understand it. So, and then I gave a chance to present, talk about it. And I asked them to record their presentation, to upload it, so we can share it. So it was very easy. It's much easier than before to evaluate the level of student of understanding of students. Yes.
Okay, I just want to make one last comment because I think
you have 2 minutes more.
Your actual course is very diverse. Yeah, there's algebra, there is statistics, there is multivariate calculus, there's artificial neural networks. So many actually major topics into one. I think it's quite interesting that you managed to put them all together as one course in 14 weeks of 3 hours. So thank you very much for the presentation.
Thank you. Appreciate for your question.
Okay, your paper is very interesting. I just have one question, that your program is online, right?
Yes, online course, yes.
Okay, so can I go into your email, not email, the online course and have a look for my student? Is it possible?
Because the university online system, we need the ID. So you may not be able to directly go to the SKKU LMS system. But if you send me an email, then I will give you all the resources that you can take a look.
Okay, thank you very much. We will contact you later.
Okay.
Very interesting topic.
Thank you.
Okay. Our presentation this morning is done. It's all complete for 2 papers. Very interesting, that 2 papers. Good morning, Dr. Wei Shiyang.
No, I have no questions, but I will say hello to everybody at the other. I think the closing is the other room, right?
Yeah, they just fixed the room.
Yes. So we'll switch the room very quickly, and I'll say hello to everybody over there.
Yes, please.
Okay. Hi,
wonderful to see you, Weiqi.
Hi.
Okay.
I will leave this room and go to the other room. Tencheng, I want to talk to you.
Okay.
Bye-bye.
Bye-bye.